How do you sort out the so-called jargon from real-world practices that work? Do the members of your organization find some business or technology advice utterly confusing? Welcome to Real Talk with Sam Holcman. In this program, we set the record straight, and in terms that business people and technology people can understand. Now, here is your host, Sam Holcman.
Welcome to this edition of Real Talk. I'm Sam Holcman. Thanks for joining me for this particular broadcast. And the title of this broadcast is The Power of Architecture. It has been shaping progress from the Industrial Revolution to today's enterprise transformation and beyond. Let's take a look at history for just a moment. The Industrial Revolution began in the mid-18th century, and it marked a turning point in human history, not only through technological innovation, but through the power of architectural thinking. While manufacturing brought these innovations to life, it was the architectural vision of the engineers that laid the foundation for unprecedented growth and efficiencies. And this led to the rise of architectural thinking. Factory system design, the shift from small-scale workshop type of approaches to vast powered factories wasn't accidental. It wasn't just make it bigger. It required architects to provide the layout for production spaces, the flow of materials, and the integration of new technologies. Their blueprints determined how factories would operate for decades to come. Architects were essential in analyzing and designing and improving not only the processes, but the machines and the systems within the factories. Architectural thinking was the blueprint for efficiencies. Explicit representations were required. As mass production became the normal approaches, the need for well-designed processes and data became paramount. Engineers were acting in the role of architects, applied scientific principles to create models and plans that optimized workflows, reduced waste, and maximized output. Architectural thinking was based on, be still my heart, frameworks. Innovations such as the steam engine and assembly line were not just inventions. They were part of a larger architectural model that envisioned how technology could systematically be embedded into production. A frame of reference was required. It wasn't accidental. Architectural thinking led to technological advancements. Inventions like the steam engine, power loom, and later interchangeable parts, assemble to order, maturity level 3 in technology, is the key to enterprise flexibility and agility. And the assembly line, which revolutionized manufacturing and required the expertise of architects and engineers to implement and manage those things. Architectural thinking was the formalization of a lot of disciplines. The complexity. You need architecture when things are complex. You don't need architecture when things are simple. But what we don't want to do with an architecture is take complex things and add complexity. So the complexity of industrial systems drove the emergence of specialized engineering fields with architectural frameworks for addressing those unique challenges. Architectural thinking led to scientific management as architecture. The very famous individual, Frederick Winslow Taylor's scientific management, was at its core an architectural approach to work. By modeling workflows, standardizing tasks, and designing training systems, Frederick Taylor's methods provided the foundation for operational excellence. Essentially, during those days, engineers provided the scientific and technical knowledge to design machines, processes, and systems, while manufacturing provided the practical environment and experience needed to implement and refine those innovations on a large scale. This synergy dramatically increased productivity, efficiencies, and the scale of production, fundamentally changing the global economy and society. This emphasis is mirrored in the Enterprise Architecture Center of Excellence, EACOE approach to enterprise architecture. It begins by what we sometimes refer to as strategic blueprinting. Architecture models, which are different than implementation models, in the EACOE methodology serve as the strategic blueprints for the organizations. They are human consumable representations of what the business wants to do in the future and is represented also by what is going on today. They define the structure of business processes, data initiatives, and systems, ensuring that every component fits into a coherent whole. No more silos. It guides innovation. Just as industrial area architects envisioned how new technologies could transform production, EACOE enterprise architects anticipate and shape how digital innovations will fit into the broader organizational landscape. This approach ensures alignment. We keep hearing that phrase, of course, throughout the history of enterprise and enterprise systems. The EACOE architecture models provide the reference point that aligns business goals, investments, and operational processes. They ensure that every initiative supports the overall vision and strategy. And one of the key things, it's the foundation and baseline for change. With the robust EACOE architecture models, organizations can adapt more quickly to change, scale efficiently, and avoid costly missteps. The architecture acts as a stable foundation as individual implementations evolve. Back in a moment.
No travel? No problem. The Enterprise Architecture Center of Excellence and Business Architecture Center of Excellence are experts in offering distance learning enterprise architecture and business architecture certification workshops throughout the year. Your experience mirrors our face-to-face workshops and are not just remote broadcasts. You will collaborate in teams across the world, just as though you were across the table. For dates and registration, visit eacoe.org and BACOE.org.
Continuing, throughout history, architectural thinking has been the catalyst for progress, whether designing the factories in the Industrial Revolution or shaping the digital enterprises of today. While implementation brings ideas to life, it's the architecture that provides the vision, structure, and coherence necessary for sustainable success. By investing in robust EACOE architecture models, organizations lay the groundwork for innovation, efficiency, and enduring competitive advantage. Now, these are complemented by the parallel in the industrial age, the manufacturing models, which we refer to as the implementation models in the EACOE methodology. Yes, the concept of two complementary sets of models is not something new. Both are required in the sequence described. And if your architecture approach isn't doing that, what you need to say is, The historical synergy between engineering and manufacturing also offers a powerful analogy for understanding this complementary relationship between architecture models and the implementation models in the EACOE methodology for enterprise architecture. The architecture models in the EACOE methodology are akin to the work of engineers during the Industrial Revolution. They provide the blueprints, the business processes, the information flows, the components, and standards. Just as engineers design machines and factory layouts, EACOE enterprise architecture and the architects involved there design the structure and operations of the organization's business and technology landscape. The implementation models correspond to the manufacturing side. They represent the realization of the architecture models. Implementation models translate the architectural blueprints into systems, software, processes, and workflow, just as the manufacturing brought engineering designs to life on the factory floor. Why does this relationship matter? Well, we see from vision to reality. The architecture models set the vision and standards. The EACOE implementation models bring them to life, ensuring that their strategic intent is realized. It matters for feedback and refinement, just as manufacturing provides feedback to engineers to refine architectures and designs. The implementation teams in EA provide insights that can lead to adjustments in the architecture models. It's a continuous loop. An open loop system produces defect. A closed loop system produces quality. Both are important. And these relationships matter for efficiency and innovation. The interplay ensures that innovation and architectures are practically viable, and the implementations are aligned with the organizational goals and optimized for efficiency. So in conclusion, just as the collaboration between engineers and manufacturers powered the Industrial Revolution, the partnership between EACOE architecture models that you'll be building and EACOE implementation models that you'll be building is crucial for successful enterprise transformation. One without the other is incomplete. Architecture without implementations remain theoretical, while implementations without architectures risk inefficiencies and misalignment. Together, they enable organizations to innovate, scale, and thrive in a complex, ever-changing environment. Yes, the concept of two complementary sets of models is not something new. It is and has been components of the EACOE methodology since its inception. Both are required in the sequence described.
Thank you for tuning into Real Talk. Be sure to join your host, Sam Holcman, again for another edition of our program. We'll have more real topics of discussion then.